I'm Jonathan Matheus, one of the founders of RavenHQ. I'm going to be going over RavenHQ in the clouds. So before I get into what we're going to talk about, I'm going to talk a little bit about what we do. We're the official hosting provider for RavenDB. Any RavenHQ users here? A few? All right, there we go. So essentially what we're offering is more like a infrastructure as a service model for running Raven without you guys having to provision databases, manage uptime, or do any of the highly available or performance monitoring stuff. So you're essentially outsourcing your DevOps for RavenDB to a highly specialized team. This company is a partnership between Nuvo 9 Consulting and Hibernating Rhinos, specifically Oranini, the creator of RavenDB. And we have pretty close ties with the Hibernating Rhinos team, so we are able to quickly answer questions and deal with any RavenDB issues. So I feel like we have a pretty unique way that we use in NServiceBus, specifically in the cloud. We use it a lot for our database provisioning. Since we have to create databases in the Amazon and AWS, Amazon, AWS, and Azure platforms, we use NServiceBus to essentially orchestrate all the things that we have to do to get this thing up running, highly available with health monitoring and DNS and all sorts of stuff using the different services in each of the particular platforms. No pun intended there with particular. And it really varies plan by plan based on what type of, if you want replication, what type of scale out needs you need, what type of uptime and availability you need. Depends on what we do there. So NServiceBus is really critical to that. We also do a lot of usage-based billing, and so we use NServiceBus to do a lot of those metric gathering and all the business rules around when these things kick off billing events. So what I hope you get from this talk is we're going to go into mainly the deployment scenarios on how to deploy NServiceBus out into Amazon and Azure, and just pitfalls or the goods and bads of each. So the main theme out of this talk that I'd like you to get is that your approach for how you deploy NServiceBus out to these clouds should really be based on your needs. Coming from a consulting company, you see a lot of clients come in and want to do it the best way, but it depends, right? These decisions that you make to go to Amazon or Azure and how to actually deploy NServiceBus out to those platforms should really be based on ROI and what your needs are, and we'll touch on those in this talk. So I'd like to start off by going through the simplest deployment model, and it's good that I went right after Andreas because I thought this was going to be a bit of a stretch to talk about the on-premise deployment in the cloud. So what we mean by on-premise is anybody running in on-premise today with NServiceBus? Okay, so lots of people. So you essentially have some servers, you have your network, you use DNS to communicate between all this stuff. A while back on AWS, which is the infrastructure as a service model, that was very hard to do because it was very flat architecture, shared network. You essentially get IP addresses, not really good ways to resolve DNS. It was really difficult. About 1 or 2 years ago, they released support for doing virtual networks on Amazon, and Azure also has support for that. And that really made it really easy to set up your cloud infrastructures pretty similar to how you do on-premise. And so the benefits of doing that is that you can continue using, MSMQ with DTC. And as much as, Andreas was saying that people are saying MSMQ is dead, a large percentage of NServiceBus users based on clientele and then also private samples of customer information is that a lot of you use MSMQ and a lot of you do use DTC. Just show of hands here, who uses MSMQ today? Yeah, quite a few of you. So, it helps you get up and running pretty quickly. And you essentially are able to do it with both platforms. So if we're comparing how to do this deployment model, this on-premise deployment model, where you're essentially running a server, physical server, and you're essentially deploying Windows services or IS or however you're doing it, and running in MSMQ, AWS and Azure both have support for it. Really, it's just the networking portion of it, which one's a bit better. I would say that AWS has better wizards and a better UI for just making it very easy to manage. Essentially, they have support through Route 53, which is their DNS service, to be able to set up a VPC, a virtual private cloud, and then be able to set up private DNSs to route to different instances of EC2 instances. You also have route tables so that you can control what can have access to the internet or what can't have access to the internet, and be able to partition your private network as well. Azure also has support for this stuff, but it's very limited support for this in the UI. You have to essentially drop down to essentially all PowerShell. And unfortunately, they don't have a DNS service. You essentially have to use DNS servers. Windows DNS service. So you have to essentially spin up a new Windows VM instance to run your DNS server. But if you're coming from an on-premise system, or if you don't have a lot of scaling needs, it's actually easier and probably more cost-effective to deploy in this model than if you were to deploy in a platform as a service model. And we'll get into a few of the reasons why. But I'd like to cover some of the soft reasons for doing this. How many people in here are part of companies that have an ops group? That's essentially what they do, is ops. So essentially, when you go to the cloud, a lot of these people run stuff on premise, and when you go to the cloud, a huge contention that you get is, how do I manage this stuff? The dev team is essentially thinking about, okay, we're going to use a lot of the queue depth and all this stuff. We can do it on platform as a service, but there's a huge learning curve for a lot of that stuff. So being able to start off as infrastructure as a service and running essentially how you run on premise, but in the cloud, is really a selling point to get buy-in from your ops team when talking about moving this stuff over to the cloud. Another thing that's interesting on running infrastructure as a service is scaling up versus scaling out. Both Amazon and Azure have pretty linear scaling costs when it comes to CPU and I/O costs and memory. I put these examples from EC2. I think these are 1-year reserved instance examples, but you'll see that the cost for CPU cores and the cost of memory is fairly linear. And this is essentially the price per day here that we're talking. So when we're talking about scaling out, another decision that you should consider when going to Amazon or to Azure is, do I really need to horizontally scale this service, or can vertical scale really solve the problem for me at around the same cost? The soft cost that we're talking about here is essentially, if you're going infrastructure as a service, you essentially have to manage these things at a very low sets of server numbers. When you get to the higher server numbers, and we'll talk a bit about that, we'll talk about automating a bunch of this stuff. But if you're doing the lowest common denominator, you do have to you essentially have to manage these servers that you're provisioning. So being able to essentially flip a switch and say, hey, this thing is going to restart and just have more resources allocated to it is beneficial. The downsides of doing that, obviously, is that you don't really have good insight into what the cost to performance gain is there, versus being able to add a box, be able to see throughput coming in, and removing that server is a pretty easy thing to do. Another option, and this is essentially Azure only, is platform as a service, where you essentially use worker roles. And what worker roles are is essentially an abstraction on a VM where they're essentially saying, hey, I'm giving you this space. You essentially can run your process, and you can scale this process horizontally. And we'll just add more instances of this one process that you have based on some sort of metrics that you can provide. So we'll get into elastic scaling, and elastic scaling is supported in both infrastructure as a service and platform as a service. But essentially, it's very easy to do that with the Azure UI. The thing is that the fact that it's easy doesn't necessarily make it very cost effective, and it also is kind of the 90% solution. We'll get into that a bit. But it's something I really consider when you have pretty serious scaling needs. Like if you're going to come in and manage 100 servers or more than 100 servers in the infrastructure as a model service, and you have a very small number of services, and you're essentially just doing this for like a few number of NServiceBus services that are core competency, you just need to scale these things out. Platform as a service to me makes a lot of sense. Also, when you have spikes in usage and you just want a really easy way to manage your scale by spinning horizontal services up and down, it makes a lot of sense. However, it can be cost prohibitive because you're essentially paying to run a process. And so, show of hands, who has more than 30 NServiceBus processes running in their production system today? Okay. So it's fairly common to see that you're running a lot of these, and they each have their scaling needs. And if you're in a lot of times you use messaging, and you have durable messaging has a lot of benefits that we've talked about over the past day, and the ability to scale is just one of the problems that it solves. It's not the only problem. And so a lot of times you're using NServiceBus, but your services don't really need that type of scale. But there are times that's the case. Well, if I have 30 services and there's, let's say, 5 or 6 that have scaling needs, I'm probably going to want to scale them independently, right? Well, that essentially means that you're essentially running them on their own processes, scaling them independently of each other, using individual worker nodes or worker roles. The other option that NServiceBus provides is to essentially have a shared space where I'm using one worker role and I'm running multiple services, kind of container style. That's a bad example, but essentially you have a shell process that's running a bunch of these bus instances. And that's a way to save money in this platform as a service model. But it essentially quickly breaks down when you have a lot of those things that you need to scale. So elastic scaling just means, hey, I'm going to react to my usage and be able to scale up and down as needed on these individual processes. That's supported in both Amazon and the Azure for both infrastructure as a service and platform as a service. With AWS, you have CloudWatch metrics, which is essentially metrics that you provide from your VM instances or from different resources like queues. Amazon has SQS, which is a queuing service that you can optionally use to run your transports on. And then you would hook that up to a load balancer to say, hey, I have these rules, like say it's queue depth or queue depth and critical time. I have these rules that I want to run, and when this thing happens, I want you to essentially spin up a new VM instance, and you essentially have IDs for the VM instance, and you say, hey, I want to spin up this new thing, and I want you to run these scripts to get it to register with the distributor. That's the kind of the AWS model. The Azure model is just a bit more intuitive when it comes to auto-scaling. On the VM instances, you actually have recipes for picking, hey, I have a queue. This is the queue. There's a whole UI for that. Here's the queue length that I want. And if it goes, if it goes more than 30 within the next 30 seconds or whatever, go ahead and spin up 1 or 3 instances or whatever you want. And that's both on a VM and then also on platform as a service. What you have less control over in Azure is that if you have custom metrics, AWS gives you a pretty good API for going and adding custom CloudWatch metrics. With Azure, it's very focused around performance counters. And so performance counters are good in NServiceBus because there's support for them with critical time, and the other NServiceBus performance counters that you get. But if you're using other metrics to determine if you're going to scale or not, it's a bit rougher in Azure. You essentially have to use performance counters to do it. When you're thinking about metrics for elastic scaling, there's really no one metric to rule them all in this when you're making these scaling decisions. You have to consider, is this process that I'm running, is it down? Am I processing messages? Queue depth isn't really very useful all on its own. Critical time from service control is a pretty useful metric, and being able to have that and to publish that to as a resource to be used to making these decisions is a pretty important aspect of being able to auto-scale. That's fairly easy with CloudWatch. You essentially, the infrastructure that's running service control would essentially just have a process running that's kicking out these performance counters up to CloudWatch. With Azure, you can also do it. You have to turn on detailed monitoring and essentially go through all of them and find the right performance counter. So it's a bit less intuitive there. With elastic scaling, you saw a bit of this yesterday. One of the main issues is trying to do automated location resolution. So essentially, I spin up this new worker process. I have this thing. Well, I have to essentially, if you're using a distributor, you have to register with the distributor. If it's a thing that's being published, you essentially have to know where to subscribe to all that stuff. It's fairly rough to do that. With the distributor, though, and with the inclusion of just a virtual private cloud now, you can deploy this AMI, and you can essentially use DNS services to go and find where your distributor is located at. And with AWS, it's fairly simple because you define your own custom DNS. Let's say it's my distributor.ravenhq.com, right? And that thing's transparent to what actual server you're using, so you can switch out the servers, or you can spin servers up and down to that distributor. And any worker node that will come in based on configuration, you can essentially just point to that DNS and it'll work. However, yesterday, we saw the death of the distributor, and I'm essentially putting, I don't know if you guys know Ace Ventura, but this slide right here is stuff that RavenHQ has not done. We're finding out a lot of this stuff early on, like you guys are. And so I just thought it was really cool because it really resonated with what we're doing. If you go this route, the DNS becomes a lot less important. What you can do is you can spin up worker nodes, right? And not necessarily even have DNS for that worker node whatsoever. You could even go as far as just using the private DNS that's given to you by Amazon and by Azure, and hook that thing up and register using the events that come out of Elastic-Scale. So every time you go and spin up or spin down a new server, you have both server events that are provided to you by Amazon and by Azure. You also have Elastic-Scale events that happen. And you can essentially register and deregister these workers based on those events, which is pretty cool. And that really gets rid of you having to have DNS management at all. Another thing that I'd like to talk about, which is kind of the Ace Ventura style of talking out of my ass since I haven't done it, is Hello Docker. Both platforms are now offering container services. So essentially, who's heard of Docker, or have served containers? Okay, so I don't have to explain a ton here. But essentially, what they're allowing you to do is running a host container, and you essentially spin up a cluster of these container hosts, and you can add these individual processes as needed. That sounds a lot like the platform as a service offering from Azure. Well, now you can do that same thing in Amazon. The benefit that you get, I think, from that versus the platform as a service model in Azure, and you can even do it in Azure, obviously, because they have container services as well, is the ability to not necessarily have to pay for these separate instances just because I want to scale this one thing out just a little bit differently. So if I have my email service and I want that in a separate process and I want to run 60 instances of them, I essentially pay for my cluster and I can spin those things up and down as needed without actually having to run a single worker role all the time to be able to scale that thing up and down. That to me is pretty huge because you're essentially completely in control of the partitioning, but you're paying essentially the same amount of money. As you need more containers, because you would essentially use the container metrics to make decisions on if you have to actually add a physical box, you can use essentially the events that are coming out of these services or the metrics that are coming out of these services to say, hey, am I running too many containers within this cluster? So that's something that RavenHQ is going to be looking a lot at over the next few months, is not only for NServiceBus, but for also our Raven instances is running in this fashion. Some random thoughts on just running in a cloud platform with something like NServiceBus. Health monitoring and notification. We have a very unique a unique topology where we're running both in Amazon and Azure. So a lot of the tool sets that we used, we wanted to kind of be agnostic of what cloud platform we were running. And these, the top two there were kind of the heaviest hitters when it came to tool selection, because a lot of times you essentially drink the Kool-Aid from the cloud platform that you're using. So they do offer services like Amazon offers Beanstalk, the ability to essentially deploy your environment using their build scripts and essentially their way of running scripts and spinning up servers based on what your code is. And Azure has similar stuff. We chose to go with Octopus Deploy for this stuff, to be able to generate our AMIs and to be able to spin up NuGet packages for NServiceBus, and to essentially do all of that deployment model with the different cloud providers for a few reasons. One, we wanted to kind of do the same thing in both Amazon and Azure. So specifically with our NServiceBus instances that run our deployments, our database provisioning, we essentially run NServiceBus instances on the physical Raven servers to help us do things that are located on the box, right? So things like setting up IaaS, setting up different permissioning, and setting up resource limits on certain stuff on our shared plans, those types of things. All of those things need to happen in a local process. Now, we could have brought that out and maybe use some remote PowerShell remoting to do all that stuff, but NServiceBus gave a really good model for that. So the hardest part of that is the deployment story, which is I have hundreds of machines out there that all need a new version of this NServiceBus process. What do I do? And they're both in Amazon and they're both in Azure. So Octopus Deploy was a really good tool selection for that, and it really hit the mark there. With health monitoring and notification, essentially what Amazon and what Azure provides, it's really good. CloudWatch and the metrics that you get, it's really amazing graphs and those types of things. And they even have notification like email notifications or text messages, those types of things. It's just that they give you the extensibility points and the tooling to do that. They just don't take it all the way. So we found that investing in products that actually can leverage that and give you a one-stop solution for doing health monitoring and for being able to page you when things are down or when things are wrong or where your metrics aren't being hit is a pretty big deal. So things like PagerDuty or server density. PagerDuty is the ability to publish events in your system and have that notify somebody via text messages, emails, and then also have the ability to have on-call staff. So your ops team will essentially really like that, and it fits in pretty well with the cloud services. We also leverage server density in a lot of cases, which provides the same. It's essentially overlapping with what CloudWatch and what the Azure diagnostics provide, but they really give you like one view of all of that stuff and very advanced graphs and views, mobile views, and those types of things. And we found that investing in that solution also was pretty beneficial. Another random thought that I had when talking about looking at choosing, Amazon versus Azure, or just running in both and seeing what the differences were, is availability. So we've had quite a few instances of our availability sets going down and those types of things in both platforms. But I'll say that it's pretty rare in AWS for an entire availability set to go down. That means that two availability groups, that's how they define them in AWS, they would both have to go down for your system to completely go down if you're running in replicated mode. That seems to be a pretty frequent occurrence in Azure, specifically in the European region. So if you're running in Europe or you're running, it doesn't happen as much on US East, but US West, it seems to happen quite a few instances of it going down completely. So that is essentially it from comparing AWS with Azure. Wanted to open up the floor to see if you guys had any questions specifically about one of those two platforms, about running in it if you were curious. Anyone? Nope.
Assuming those AWS events, what does that look like? Are you assuming those from those new machines? How do they publish? How do you use that?
Sure. So what Amazon provides is they have a queuing service called SQS. So it's essentially topics, if you've ever used TIBCO or anything like that, but it's essentially a queue. And you can essentially pull that thing, or you can set up, they also have services called Lambda, where you essentially can run a process, a script, when one of these events happen. So you can essentially do it all in AWS infrastructure, where I essentially say, hey, I have this PowerShell script, or I have essentially this JavaScript code that I want to run that just goes and spins up an instance. That's one option. Another option is just using the load balancer. So the load balancer has rules where you can essentially say, hey, when this thing happens, I just want you to spin up an instance. That's probably the easiest model to go with. But if you're probably going to want to do some things around, hey, I want to register with the distributor, those types of things. You can do that in the startup of your AMI script. But it would probably be easier to do it all as one, essentially one step. So I would opt into doing it with something like listening to the queue and doing something either in NServiceBus or in Lambda or something like that.
What do you do to abstract the differences between platforms?
Excuse me?
What do you do to abstract the differences between the AWS and Azure platforms?
So what we've done there is just using messaging. That's why we're using NServiceBus. So essentially, the actual creation of a DNS, those types of things, we essentially we have rules around, based on what region you are, where that message should go. So we're essentially just saying, hey, go set up this DNS, and we have handlers both running in Amazon and in Azure to essentially read those messages. Now, the actual external stuff, like using the external services, we essentially run that in Amazon, and they're just talking to Azure services. Really, the place that we use both cloud providers, running the same services in both clouds, is with the code that actually does stuff on the actual Raven server boxes. And there, you don't actually use AWS or Azure specific things. It's mainly just Windows specific things or PowerShell specific things. There are certain cases where you do have to drop down to that, and at that point, we're essentially just using PowerShell underneath to do it. But really, it's just having commands that say, hey, create a DNS in Azure, right? Or having a command, create DNS in Amazon. They're strongly typed messages to do those things, and we make those decisions on what command we're going to send based on what region you're running in, what region you selected for your plan. Yes, so it definitely is. Now, when it comes to the latency on disks, I mean, you have IOPS, and you're going to pay for it more. It is an issue, but you're essentially going, when you're talking infrastructure as a service, you essentially pay for what you want to use on disks. So yes, running really fast disks in Amazon, AWS, you're going to essentially pay for that. But you can get some pretty good speeds there. Not as much, because you're essentially running in a VPC. I haven't really seen a lot of latency there. Really, when you start talking about latency is when you start talking about using the queuing systems that come from the different cloud providers, which that's a pretty good point that I kind of glossed over on my slides here. So we talked about infrastructure as a service as an option. So in that model, or in the platform as a service model, like a platform as a service model, you can choose to run non-MSMQ. You can choose to run Rabbit. You can choose to run Amazon SQS or Azure, the Azure queues that Andreas talked about. So when you do that, you're essentially not running DTC anymore. But there's still a benefit to running that way, because of the fact that you have more control over grouping your services running on a physical machine. But so when you go that route, you do see more latency, obviously, because the queue's remote, right? Anyone else?
Can you talk a little bit more about the usage-based billing? How does that fit into?
Sure. So our usage-based billing? So the way we do usage-based billing is that we essentially charge you, your plan has essentially X amount of included storage, right? So if you're running like an enterprise one, you have X gigs of included storage. Well, when you get to that included storage, you don't want to just stop what you're doing and not do anything else. You're going to want to essentially add storage. And we're in a unique space where the more storage you have, essentially we're doing indexing, right? That's essentially what we're doing. So we've essentially priced our services by gigabyte that's not on your storage. But you're essentially not just paying for hard drive space there, you're essentially paying for the memory and for the CPU space that is estimated with that the extra gigabyte that you have. So unfortunately with Raven, figuring out what your disk size is or what your database size is a very resource intensive operation to do. So it's not like we can be constantly getting that stuff, right? We have process sagas that are sitting out there making decisions on the other thing that's a problem is if you don't, in order to manage resources, if you haven't hit your database in a day or two. We essentially put that thing in sleep mode until you ask for your next request. So it's killer for us to go in. We can't just run a batch process that says, hey, go find out all my usage, because then we would be spinning up a ton of databases, and it essentially will cost a lot of CPU and a lot of memory to do that. So we have a lot of heuristics around. When was the last time I heard about this process? When was the last time that they made a query? If they haven't queried anything in a while, well then I'm not going to bother getting usage on it, or a store, not a query. If they haven't stored anything in a while, I'm not going to bother getting usage. I'll just use my usage from yesterday, right? And then at the end of that month, we essentially get you buy blocks of gigabytes. So we essentially get those things in our billing system and make decisions based on the models that were generated via events that came out of the usage business component. Any other questions? No? Well, then I'll go ahead and wrap up here. If you guys have any specific questions around AWS and Azure, just come talk to me.